Hello everyone and welcome back to our videos. Today we will continue on physics chapter 2 general book, and we arrive to section D, aerodynamics. We will talk in this video about the trim controls and some types of trim controls. Also we will talk about the four forces of flight and how an airplane produces lift. And the last thing we will talk about is the wingtip vortex. At the beginning of this video, I will talk about the trim controls. The trim tabs are small movable portions of the trailing edge of the control surface. These movable trim tabs are controlled from the cockpit and alter the control surface camber to create an aerodynamic force that deflects the control surface. The trim tabs can be installed on any of the primary flight controls. So we will focus here the tabs it will used on the primary flight control surfaces. If only one tab is used, it is normally on the elevator. This is used to adjust the tail load so the airplane can be flown hands off at any given airspeed. As you see here, this is the horizontal stabilizer of aircraft, and here we have the elevator. On the leading edge of the elevator we have the trim tab. Large aircraft obviously require larger control surfaces and more force is required to move them. To assist in moving these large surfaces, control tabs are mounted on the trailing edge of the control surfaces. For an example, a servo tab, and this a type of the tabs. We talked about the trim tab, and the second type of the tab is the servo tab. Servo tab is connected directly to an aircraft's flight controls and moves in a direction opposite to the desired control surface movement. As the tab deflects into the airstream, it forces the control surface in the opposite direction. As you see here, we have the elevator, and here we have the servo tab. And you see the tab, it will move in the opposite direction of the elevator. The elevator will goes up, and the tab it will go to the down position. Balance tabs, and this the third type of the tabs. The balance tabs receive no control inputs but are connected to the main structure. When a control is activated, the balance tab deflects into the airstream and helps to move the control surface. Here in this figure illustrate the balance tab, and you can see that the elevator will move up but the tab will goes to the down position, and you have to take this in your consideration. The balance tab connected to the structure, not to the flight control. The second thing we will talk about is four forces of flight. During flight, there are four forces acting on an airplane, and they are lift, weight, thrust, and drag, as we see in this figure. This the lift, the aircraft goes up, and this the thrust when the aircraft goes forward. This the weight, the aircraft goes to the down position, and the last force is the drag. Lift is the upward force created by the effect of airflow as it passes over and under the wings. It supports the airplane in flight. What about the second force, weight? Weight opposes lift. It is caused by the downward pull of gravity. The third force, thrust, is the forward force which propels the airplane through the air. It varies with the amount of engine power being used, opposing the thrust. The thing that opposing the thrust is the drag. The drag is the last force of flight, which is a backward or retarding force that limits the speed of the airplane. Before we talk about how the airplane produces lift, we will start to talk about the lift itself. Lift is the key aerodynamic force. It is the force that opposes weight. In straight and level and accelerated flight, when weight and lift are equal, an airplane is in a state of equilibrium. During flight, the pressures on the upper and lower surfaces of the wing are not the same, although several factors contribute to this difference. The shape of the wing is the principal one. The wing is designed to divide the airflow in two areas of high pressure below the wing and areas of comparatively lower pressure above the wing. This pressure differential, which is created by movement of air about the wing, is the primary source of lift. Bernoulli's principle. The basic principle of a pressure differential of subsonic airflow was discovered by Daniel Bernoulli. The Daniels-Bernoulli simply says as velocity of the fluid or air increases, the internal pressure decreases. And here the lift according to Bernoulli's principle. The air on the upper wing, the velocity of the air will increase and the pressure will decrease. But on the lower wing, the velocity will decreases, so the pressure will increases. Here we have a differential pressure that will causes the lift. Also, we have another thing that help the aircraft to lift. Now, the question said that how an airplane produces lift. The airplane produces lift by many things. The first thing, and we illustrated that, Bernoulli's principle, and simply says, as the velocity of fluid or air increases, its internal pressure decreases. The second thing, the velocity of airflow on the upper wing increases and pressure decreases. The third thing, the velocity of the airflow on lower wing decreases and the pressure increases. There will be a differential pressure between the upper wing and the lower wing, about 75% of total lift. So here the total lift will produced by 75% by the differential pressure between the upper wing and the lower wing. The remaining lift is provided by the wing's lower surfaces as air streaking the underside the underside is deflected down. According to Newton's third law of motion, for every action there is an equal and opposite reaction. Therefore, the air that is deflected downward by the wing also produces an upper lifting or reaction, about 25 of the total lift. Air flowing over the top of an airflow reaches the trailing edge in the same amount of time as air flowing along the relatively flat bottom. Since both the upper and lower surfaces passes through a block of air at the same speed, the air flowing over the curved upper surface travels further. This means it must go faster, resulting in lower pressure above the airfoil and a greater pressure below. An airfoil is especially designed to produce a reaction of the air that passes over it, and we will talk about the airflow in details in the second video. This difference in pressure is the main source of lift. For more emphasizing, we will talk about the Newton's third law of motion in details. The remaining lift is provided by the wing's lower surface as air streaking the underside is deflected downward. According to Newton's third law of motion, for every action there is an equal and opposite reaction. Therefore, the air that is deflected downward by the wing also produces an upward lifting reaction for assist to the aircraft to make lifting, and this lifting it will be 25% of the lift. The last thing we will talk about today, the wingtip vortex. Wingtip vortex are caused by the air beneath the wing, rolling up and around the wingtip. This causes a spiral or vortex that trails behind each wingtip whenever lift is being produced. Upwash and downwash refer to the effect an airfoil exerts on the free airstream. What's the meaning of upwash and downwash? The upwash is the deflection of oncoming airstream upward and over the wing. What about the downwash? The downwash is the downward deflection of airstream as it passes over the wing and past the trailing edge. And here we say the the wingtip vortex.